Sound is everywhere. It's how we experience the world around us. But what exactly is sound? In simple terms, sound is a form of energy that travels as waves. Imagine tossing a pebble into a still pond. You see ripples, waves spreading out from where the pebble hit. Sound works in a similar way, but instead of water, it needs a medium like air to travel. When something vibrates, it creates disturbances in the surrounding medium. These disturbances travel outward, carrying energy with them. When these waves reach our ears, they cause our eardrums to vibrate, and our brains interpret these vibrations as sound. So, whether it's a bird's chirp, a car horn, or a beautiful melody, it all boils down to vibrations traveling through a medium and reaching our ears.
Like any wave, sound has certain properties that define it. These properties determine how we perceive sound, its pitch, loudness, and quality. Frequency is one crucial property. It refers to how many sound waves pass a point in 1 second. We measure frequency in hertz. Higher frequency means more waves per second, and we hear that as a higher pitch. For instance, a piccolo produces high-frequency sound waves, resulting in a high-pitched sound. Then there's amplitude. Imagine those ripples in the pond again. The bigger the ripples, the more energy they carry. Similarly, sound waves with larger amplitudes have more energy. This translates to what we perceive as loudness. A whisper has a small amplitude, while a jet engine has a much larger one, hence the difference in loudness. These properties work together to create the rich tapestry of sounds we hear daily. Understanding them helps us appreciate the complexity of sound and how we experience it.
We've all experienced echoes. You shout in a canyon, and your voice returns moments later. This phenomenon occurs because sound waves, like light waves, can bounce off surfaces. This bouncing back is called reflection. When sound waves encounter a hard surface like a wall or a cliff face, they reflect. If the reflected sound waves reach our ears distinctly from the original sound, we hear an echo. The time delay between the original sound and the echo depends on the distance between the sound source, the reflecting surface, and the listener. But reflection doesn't just create echoes. It also plays a crucial role in how we hear sound in enclosed spaces. This is where reverberation comes in. Reverberation is the collection of reflected sounds from surfaces within a space, like a room or a concert hall. These reflections, although weaker than the original sound, can persist even after the original sound stops, creating a lingering effect. This reverberation is what gives rooms their acoustic character, making some sound live and others dead depending on how much the sound reflects.
Section 4. The need for speed. Sound's journey through stuff. We know sound needs a medium to travel, but did you know that sound travels at different speeds depending on the medium? It's true. The speed of sound is not constant. It depends on the material the sound wave is traveling through. Imagine those sound waves as tiny travelers. They move by bumping into the particles of the medium. In air, these particles are relatively far apart, so sound travels at a leisurely pace, about 343 meters per second. But put that sound wave in water, where particles are packed much closer together. Now, those sound travelers can zip around much faster, reaching speeds of around 1,500 meters per second. That's more than 4 times faster than in air. Solids with their tightly packed particles provide the fastest lane for sound. In steel, for instance, sound can zoom along at a whopping 5,000 meters per second. That's incredibly fast. So the denser the material, the faster sound travels through it. Understanding this helps us explain why some materials carry sound better than others, and has important implications for various fields, from designing musical instruments to exploring the depths of the ocean.
Section 5. Sound at work, from healing to music. Sound isn't just something we hear, it's a powerful tool we can use in countless ways. From medicine to navigation to creating beautiful music, the applications of sound are incredibly diverse. In medicine, ultrasound technology uses high-frequency sound waves to see inside the human body. These sound waves bounce off organs and tissues, creating images that doctors use to diagnose and monitor various conditions, from pregnancy to heart problems. Ships and submarines use SONAR, which stands for sound navigation and ranging. Sonar systems emit sound pulses and then listen for the echoes that bounce back from objects underwater. By analyzing the time it takes for the echoes to return, sonar can determine the location, distance, and even the shape of underwater objects. Of course, we can't forget music. Musical instruments are essentially devices designed to produce specific sounds. Whether it's the vibration of strings in a guitar, the air column vibrating in a flute, or the stretched membrane of a drum, each instrument manipulates sound waves to create the melodies and harmonies we enjoy. These are just a few examples of how we harness the power of sound in various fields. From medical breakthroughs to exploring the hidden depths of our oceans, the applications of sound science are truly remarkable.
Section 6. The Silent Void. Why space stays quiet. We've talked about how sound needs a medium to travel. This fundamental fact explains why space, the vast expanse beyond Earth's atmosphere, is eerily silent. In the vacuum of space, there's practically nothing for sound waves to travel through. No air, no water, no tightly packed particles to carry those vibrations. It's a vast emptiness. Imagine trying to have a conversation underwater with someone far away. Your words wouldn't reach them because the water would muffle the sound. Space is like that, but on a much grander scale. So despite what you might see in science fiction movies, those epic spaceship battles would be eerily silent in reality. No booming engine noises, no laser blasts, just a deafening silence.
Section 7. Tuning in. Why sound science matters. Understanding the science of sound is about more than just knowing how our ears work. It's about appreciating the amazing world of vibrations and how they shape our experiences. From the chirping of birds to the roar of a rocket launch, sound paints a vivid tapestry of our world. By understanding the properties of sound, how it travels and how we use it, we gain a deeper appreciation for the symphony of vibrations that surround us. Sound science has led to incredible technological advancements like medical imaging, underwater exploration, and the creation of countless musical instruments. As we continue to unravel the mysteries of sound, who knows what other amazing applications we'll discover. So, the next time you hear a beautiful piece of music, feel the rumble of thunder, or marvel at the echo in a canyon, take a moment to appreciate the science behind those sounds. It's a fascinating world waiting to be explored.